Synthetic division. So this is Appendix A, Section 4. So some of you may have already done synthetic division. Some of you may have done it and not even realize that you've done it. Others of you may be more familiar with polynomial division. So let's start with an example of polynomial division. Remember, polynomial division is just long division for polynomials. It follows the same method as you do for regular long division. So here I have 6x cubed minus 13x squared minus 32x plus 10 divided by 2x minus 7. Now, one thing that I will point out about polynomial division, and the same thing fits for synthetic division, is that each term or each degree term in the polynomials is kind of like a place value when doing standard long division. If you have 1,234, you've got a 1 in the thousands place, a 2 in the hundreds place, a 3 in the tens place, and a 4 in the ones place. Now, if you have 1,004, you have a 1 in the thousands place, a 0 in the hundreds place, a 0 in the tens place, and a 4 in the ones place. You can't just ignore those two zeros in the middle of there and treat it as 14. Well, the same thing is true with polynomial division, that you have to have all of the degrees starting at the highest degree going down to a degree of 0. So if you're missing a term, if we had 6x cubed minus 13x squared plus 10 and we didn't have an x term, you have to fill that in as 0x. That would be like leaving out the tens place and compressing a number, a 4-digit number, to be a 3-digit number. So just keep that in mind. Same, it's true for the dividend and the divisor. So either one of those, you have to have all the terms. Whatever degree it starts at, you need to count all the way down to x to the 0th power. This one's good. It has all those terms in there, so it's not a problem. If we were missing something, we'd have to put 0, whatever it happened to be, 0x or 0x squared, fill in a placeholder. Otherwise, everything gets messed up. So when we're dealing with polynomial division, we start by looking at the first term in the dividend and the first term in the divisor. Don't worry about this other term. All you're doing is comparing first terms, and then you go back and do the rest of the process. So 2x goes into 6x cubed how many times? Well, 6 divided by 2 is 3. X cubed divided by x is x squared, so 3x squared. So we're going to put that in the right place value. We're going to put it right over the x squareds. We're now going to multiply through, just like we would in long division. 3x squared times 2x gives us 6x cubed, and 3x squared times negative 7 gives us negative 21x squared. Okay, just like we would with long division, we're going to subtract 6x cubed minus 6x cubed, cancels out. That's what our purpose was. Negative 13x squared minus negative 21x squared, so that becomes negative 13x squared plus 21x squared, gives us positive 8x squared. We bring down the next term, minus 32x. We're now going to do the same thing we did. How many times does 2x go into 8x squared? It goes in 4x times. 4x times 2x gives us 8x squared. 4x times negative 7 gives us negative 28x. Now we subtract 8x squared minus 8x squared, cancels out. And please make sure that you do actually do the subtraction. If you do the subtraction, then you're less likely to make mistakes than if you just go, it cancels out. I see too many times where students go and they know it's supposed to cancel out, so they just cancel it even though it really doesn't happen. And then negative 32x minus negative 28x, so negative 32x plus 28x gives us negative 4x. Bring down the next term, plus 10. How many times does 2x go into negative 4x? Negative 2 times. Negative 2 times negative 2 times 2x gives you negative 4x. Negative 2 times negative 7 gives you 14. Subtract negative 4x minus negative 4x gives you 0. 10 minus 14 gives you negative 4. So now there's nothing else to divide. So in long division, we've got a couple options here. You just say a remainder. You put the remainder over the divisor, or you keep dividing into the other into decimal places. Well, we don't have decimal places here dealing with polynomials. So what we're going to do is we're going to put it over the divisor. So we have 3x squared plus 4x minus 2 minus 4 over 2x minus 7. So that's our example of polynomial division. You should have done this in the past. If you don't remember polynomial division, then by all means go and look it up and watch some examples for it. So now let's move on to synthetic division. Well, what is synthetic division? Synthetic division is just an abbreviated form of polynomial division. The whole purpose of it is it eliminates writing terms multiple times. And we'll pop back to this slide to show you that. It's also going to change subtraction to addition. And basically, it simplifies the polynomial division process. So I'm just going to quickly bounce back to that previous slide. And if we look at it, we see a number of things here. First of all, 6x cubed, 6x cubed. All we did was we purposely made those match up. So all we did was copied that number down. We came out with 8x squared. Well, we purposely made it match up, so we copied that number down. We have minus 32x here. We pulled it down here to write it again. We had negative 4x, so we did everything to make this equal to negative 4x. We pulled down this 10, right? So we can see that we have a number of things. Oops. We have a number of terms that were just written a second time. 6x cubed got written twice when we knew it was going to happen. So why did we repeat writing 6x cubed? 8x squared got written twice. 32x minus 32x got written twice. Negative 4x got written twice. Plus 10 got written twice. So all of those things got written over and over again as part of this process. Also, because we're keeping our place values or our terms in line, writing x cubed, x squared, x, and obviously there's no x to the 0 there, but writing all of those is superfluous. We know, since we're including from the largest degree to the smallest degree, and that's going down to the constant term, that we have the x to the 0 term, and then we have the x term, the x squared term, the x cubed term, the x, it's just going to go up. So those, writing down all these x to the whatever power is just extra work. Look at all these x's we wrote, x squared cubes and x squareds and x's. So we wrote 2x cubes, we wrote 5x squareds, we wrote 6 x's. All of those can be eliminated because we know that's what's going to happen. The other thing we did is, this was subtraction, 6x cubed minus 13x squared minus 6x cubed minus 21x squared. Well, we learned way back in arithmetic that to subtract signed numbers, we convert them to addition of signed numbers by changing the sign and of changing from addition and subtraction to addition, and changing the sign of the second number so that it did the same thing. Well, we can do the exact same here. Instead of subtracting, and isn't that where we run into issues? You go and start doing this and you make mistakes when you're subtracting, just like we did when we first learned arithmetic. So if we turn everything we do into addition, we can do that by changing what we're subtracting into adding a negative of what it was. So that's what this whole synthetic division process is. we're trying to make it simpler. We eliminate writing terms multiple times and writing those x to the whatever degrees. We change subtraction to addition so that we can add because it's simpler for us to add. We're less likely to make mistakes. And it just simplifies the whole polynomial division process. So let's see how this works. Exact same problem that we just did, the 2x minus 7 divided into 6x cubed minus 13x squared minus 32x plus 10. So what do we do to write this as synthetic division? Well, we eliminate those x terms, x squared, x cubed. We don't need that, okay? So we have 6, negative 13, negative 32, and 10. We take this negative 7 and turn it into a positive 7 because remember, we're going to do this multiplication and then turn it in, and then we're going to subtract it. Well, now we're going to, if we're dealing with a negative of whatever it was, we can add it. And the whole purpose of this is to get it equal to that first term. So that first term is not needed. But since this has a 2 in front of it, we are going to need to divide by that as we go through the process. So basically, we're going to take the leading term, we're going to take its coefficient, and we're going to make it a divisor at the bottom of our process. We're going to take the other terms and negate them. In this case, we only have one other term, so that negative 7 becomes positive 7. So the process is as follows, that we bring down the x, the first term, 6. So 6 comes down, and then we divide it by 2, because that's what we have here. 2 was our leading coefficient, which gives us 3. We're then going to take that 3 and multiply it by 7, which gives us 21. That goes into the next column. Now we're going to add negative 13 and 21, which gives us positive 8. Positive 8 divided by 2 is 4. 4 times 7 is 28. Negative 32 plus 28 gives us negative 4. Negative 4 divided by 2 is 2. Negative 2 times 7 is negative 14. 10 plus negative 14 gives you negative 4. And the reason we do these divisions at the front are so that when we do our multiplication, we get the right thing. So we don't divide that last one. So now that we have those, we look at the leading terms. We had 6x cubed and 2x. So 6x cubed divided by 2x gives us 3x squared. Or you can just look at the x cubed divided by x gives us x squared. So the first term of this must be x squared. So 3x squared plus 4x minus 2. And since we got down to our constant term, this must be the remainder, minus 4 over 2x minus 7. And notice that that's exactly what we got with long division. Well, that may have been a little bit of a complicated process, and initially it just takes a little bit of time to get used to it. But let's look at another one, and this one's got more into it. 6x cubed minus 13x squared minus 32x plus 10 divided by 3x squared plus 4x minus 2. So what we're going to do, and remember what I said, we're going to take the leading term and its coefficient is going to be a divide, and what we're going to divide by on the bottom. The other two terms we're going to negate. So this negative 4x is going to turn into a negative, this plus 4x is going to turn into a negative 4, and this negative 2 is going to turn into a positive 2. We're going to eliminate all the x to whatever degrees they are, and we get this. So 6, negative 13, negative 32, 10. So just taking the coefficients, and then we have negative 2 gets turned into 2, 4 gets turned to negative 4, and that leading coefficient 3 becomes what we divide by on the bottom. Notice I am lining up these terms in their coefficients, 2, negative 4. We're actually going to use 2 lines to do this. So we're going to start out and we're going to bring down 6. Then we're going to divide it by 3, which gives us 2. And then we're going to multiply. Remember, these things shift over, so we're going over to the next place. 2 times negative 4 is negative 8, and 2 times 2 is 4. Okay, we've now completed this one, so we have negative 13 plus negative 8 gives us negative 21. Negative 21 divided by 3 is negative 7. Negative 7 times negative 4 gives us positive 28, and negative 7 times 2 gives us negative 14. Notice we have this angle that we're multiplying by. Now we have this one filled up, so we have negative 32 plus 4 plus 28, which adds up to 0. 0 divided by 3 is 0. And I do that for the sake of completeness, because we want to follow the same process no matter what happens here. And now we would go to multiply through here, but we realize we only have space to multiply by the negative 4. We don't have anywhere that we can put that multiplication by 2. So we're done with that. So we're not going to fill here, and we're just going to add it. 10 plus negative 14 is negative 4. So now we can look at it. Well, we had x cubed divided by x squared, making this leading term x. So we have 2x minus 7 plus 0x minus 4 over 3x squared plus 4x minus 2. Obviously, we don't write in the 0x, so we just say minus 4 over 3x squared plus 4x minus 2. Once you get down to that constant term, whatever's left, however many terms it is, must go be the numerator of your final rational fraction here. So you have negative 4 over 3x squared plus 4x minus 2. And that's synthetic division. Go through these and practice them and try doing some on your own. Remember, just do regular polynomial division and then throw it into synthetic division and see if you get the same result. You should. And once you get used to it, you'll actually find synthetic division to be a lot faster and easier than polynomial division was. So that is synthetic division.